Hi, so on the second common assessment, we have some various problem types. We have 16 problems altogether, but I'm going to show you 8 sample problems. So these are the same type of problems that we'll see on the common assessment, the second common assessment, but these are not the answers to the common assessment. These are just examples to go by. If you can understand these examples, then you should do just fine on the common assessment. So let's take the first one. So what we want to know is, what is the length of the base of this triangle? Well, first of all, let's identify the parts. So we have the height, we have the hypotenuse, and we have the base. So one thing that we noticed is that we know the height is 3 units, we know the hypotenuse is 5 units, but we don't know the base, and we're using this x. X is often used when we don't know the exact number. We know that it's a particular number, but we don't know which one it is right now. So we're going to solve to find the missing variable. So, well, side A, we know, is 3 units long. But we're squaring side A, so we have to square that 3. And we're going to add that to however many units side B, which is our base. Well, we don't know how many units that is, but it is a number. So we'll use that x in place of B. And since we're squaring B, we'll square that x. And then we do know how long side C is. Our hypotenuse is 5 units, and we're going to square that. We do that because this is a Pythagorean theorem. And we use this as a pattern or a formula to follow. And that is going to help us identify the length of one of our sides. In this case, it's the base. So we want to get rid of the exponents first because of the order of operations. So 3 squared, which is really 3 times 3, that's 9. We don't know what the x is yet, so we leave it alone. And 5 squared is 25. So we want to get x all by itself. So what we're going to do is we're going to move this 9 from the left side to the right side. And we do that by subtracting 9, because 9 minus 9 is 0, and that cancels out. But because we have an equation, we do the same thing to the right side. So we have x squared equals 25 minus 9 is 16. But we're not done yet, because we want x, not x squared. So we need to undo the squaring. So what we want to do here is square root. What we do to the left side, we have to do the right side of an equation. So if we square root x squared, we just get x, because we're trying to find out what multiplied by itself will give you the x squared. Well, x, because x times x equals x squared. So if we square root that, all we have left is x. Well, we want to square root that 16. That tells us x equals 4. And we know that's right, because if we check, we could say 3 squared plus 4 squared equals 5 squared. So 3 squared is 9, plus 16 equals 25. 9 plus 16 does, in fact, equal 25. And we produce a true statement. So we do know that this is correct.